So today I'm going to explain you about the direct sequence spread spectrum. So this is the short form DSSS. So first of all, we would like to go through the definition. What does the direct sequence spread spectrum means? A direct sequence spread spectrum is a transmission technology which is used in the local area network transmission. So in this technique, we would be combining our user data with some specific chip code. The chip code is of the higher data rate than the user data, so that it can be encrypted and other user cannot get that. So I would be reading some of the examples. So here are some uses of the direct sequence spread spectrum. Direct sequence spread spectrum modulation technique is used for the digital transmission through airways. It was originally developed for the military use so that our data can be secured. Our data cannot be leaked or our data cannot be traced by anyone, and it is also resist to the jamming, as our data is combined with the chip code which is having either 8-bit chip code, 64-bit chip code, 128-bit chip code. Means one data means one data is the 1 byte of the data is connected with the 8 byte 64 byte 128 byte of chip code. So now I'm going to explain about the technique, what it really does. So before further going into DSSS, you must know what is the use of the XOR operation, or what is the XOR operation means. XOR operation gives the output whenever there is 0 and 0, the output would be 0. Means it detects inequality. Whenever there is two different bit, means suppose there is a 0 in one gate and 1 in another gate, the output would be 1. So it detects inequality, and for the equality it will give the result 0. So further I'm going to explain. This is our user data, which is 0 and 1. There is 2 byte of user data, and further this is our chip code, which is 8 byte of chip code for every byte of data, and furthermore we would be having another same 8 byte of chip code for other bit of data, and now our spreaded signal would be made just by the XOR operation of signal data and spreaded signal. So I'm going to explain about only one bit. So we have here 0, and the user data is also 0. So for 0 and 0, the XOR would be 0. So it is a bump upside, right? For chip code, there is next bit is 1, but our user data is the same. So it is 0, 1 and 0 would be 1, as it is inequality, and XOR always detect inequality. Further going, it is having 0 in the next bit of chip code, and our user data is 0. So 0 and 0 would be 0. Furthermore, 1 and 0 would be 1. 0 and 0 would be 0. So likewise, our chip code spreaded signal is made. The main use of the DSSS would be in military, and where our information must not be leaked. At that time, the chip code used is around 128 bits, so that no one can jam and no one can get information about country so now I'm going to explain you about the direct sequence spread spectrum applications. So there are many applications, but mainly applications are in mobile technologies or in the military bases or the military communications or whatever. So CDMA cell phone is having one of the main application in DSSS. So whenever we are calling to anyone, we are not only the one who is calling to another person. So there are many, but our voice is converted into digital form, and that digital form is converted into spreaded signal, and the chip code which the company has used for converting our voice into a spreaded signal, the same chip code would be having at the receiver side, and then other would be not having the same chip code, but the one who is receiving it would be having the same chip code, so that same data can be obtained and converted communication. So now I will show you my the project which I have made. I have made the code of the DSSS in C language, and further I will be showing you. So now I am going to explain you about the code which I have made in the C language. I have used the files graphics.h. So this is my code. So this is my code which I have made for the DSSS. I have used the graphics.h for the graph and the line codes. Further, this is int gd equals to detect. This is the integer variable which we need for the graphics. Further, I would like to explain the which array I have used for the which code. So T1 is for the data rate code 1. Code 1 is for the chip code 1, code 2 is for the chip code 2, R1 is for the transmitted signal 1, R2 is for the transmitted signal 2, and J and I are for the loops. D1 is for the data rate 1, means the data with respect to 1 and data with respect to 2. And furthermore, so here it will ask you for the 2 bits of data. So the for loop runs for the twice, and it will ask it will take 2 integers. Furthermore, it will ask for the first chip code which is of the 8 signal, so that the for loop runs 8 times and it will get 8, and same is for the second. Now it will show you all data and chip code 1 and chip code 2. So here comes the logic. First of all, I would be explaining the operation of an XOR gate detects inequality. Whenever there is an 1 1, the answer would be 0. For every bit of data rate, we would be having 8 bit of chip code, as I have explained earlier. So whenever there is Ti, that is data of 1 bit of data is equals to 1 bit of code, the answer would be 0, and else whenever there would be inequality, the answer would be 1, right? Yes, the answer would be 0 whenever there would be equality, and answer would be 1 whenever there would be inequality. The X I have used for storing the next bit of data, and this is same. The logic is the same, but it is for the chip code 2, right? It is for the chip code 2. Further moving, it will show you the transmitted signal 1, which is of the 16 byte, this is because we have 2 byte of data, and other 8 for each 1 byte of data we would be having 8 byte of transmitted signal. And further, for transmitter 2, same, the signal would be of the 16 byte. Further, it will show you the transmitted signal 1 and the data received. Now it will show you all about graphics. So now I'm going to run my code. So here I'm running my code. No error. Yeah, welcome to the direct sequence spectrum. Press enter to continue. I am entering to continuing. So it will give instructions what you would be giving as an input, and what you will get as output. We would be implying data signal and spreaded signal. The received data would be different, and it will show you the spreaded signal that I will show. So first of all, we would be entering the data signal, which is of the 2 bytes, so 1 and 0. This is our data signal. Further, I'm pressing enter to continuing. So this is our chip code 1. Chip code 1 is of the 8 bit, so this is 11110. Further would be 1, right? This is our chip code 1. Entering the chip code 2 would be 101011, 0, yeah, and likewise. So now it will show you that data signal according to XOR operation, 1 and 1 would be 0, 1 and 1 would be 0, 1 and 1 would be 0, and likewise for the chip code 2, 1 and 1 would be 0, but while 1 and 0 would be equals to 1. So this is our chip code 1, this is our chip code 2, then transmitted signal 1, transmitted signal 2, and it will show you that the same data is received at a receiver side, because the receiver side is also having the same chip code as we are having whenever we are transmitting the signal. Transmitted signal is different for the different spreaded signal, right? It will so this is more like XOR operation. this is the data with respect to signal 1, and this is data with respect to signal 2, which we can see that 8 bytes of 1, as we have entered the first bit as 1, and second 8 bits of 0 as we have entered 0. So now it will show you all data signals in the form of the lines. So this is the data. This is data which we have entered of 2 bytes. So this is 1 and this is 0. This is the zip code which we have entered for the 8 byte. So this is 8 byte of the chip code. This is chip code 2 which we have entered, and further this is transmitted signal which is of the 16 byte. So now it will show you transmitted 1, transmitted 2, and further the transmitted 1 is we can get transmitted 1 from XORing data and chip code 1. Likewise, for transmitted 2 we have to XOR data and chip code 2. Further, at received 1 we can obtain from the chip code 1, and transmitted 1 we can get received 1, and likewise on. Thank you for watching.